Welcome. I'm Paul with the Energy Conservatory, and welcome to our webinar titled TECLOG3 for blower door testing. If you're having trouble with the audio, go to the meeting pull-down menu and choose the audio setup wizard, and it'll step you through getting your audio up and running. And type in questions as you think of them. We will be typing in responses to some of those questions, and then we'll also be covering some of them at the end. There will be a link on our website to the webinar, so you can view it again in the future if you'd like. And please give us some feedback on what type of webinars you'd like to see in the future. We're always trying to supply our customers with the technical information that they need, and give us some ideas. This is the second in a series of 4 TECLOG3 sessions. The first one was the basics of an intro to TECLOG3 and using it to data log pressures. The second one will be on setting up and doing a single fan blower door test. The next one will be on multifamily multi-fan testing. And the fourth one will be specific to testing large buildings as a single zone. Single fan, we'll be doing a single fan multi-point test during this session, and we'll be viewing the results, and we'll be exporting the data from TECLOG3 into TECTIDE Express to generate a report. So we recommend that you download the free copy of the TECLOG3 software from our website, and go through the setup process to get it set up on your computer and launch the software. We certainly recommend that you download a copy and practice between these webinar sessions to get familiar with doing a blower door test before we start getting into more sophisticated uses of TECLOG3. I'm more of a hands-on learner, and I would think a lot of you are, and just watching a webinar isn't going to be enough. You really need to download it and get some hands-on practice with it before the next webinar session starts. So download it and practice a blower door test on your house, and if you have any questions, you can pull up the pre-recorded webinar, and it'll help you, hopefully help you help answer your questions. And you can also feel free to call us at the Energy Conservatory, and our tech support can help talk you through any issues you might be having also. So the options for connecting the DG700 to your computer, for the computer to take control of your system, you'll need to run your fan connect cable from the gauge down to your speed controller and turn the speed controller on, so the computer can talk to the DG700, and then the DG700 can talk to the speed controller. And connecting the gauge to your computer, there are a few options. If you've got a gauge newer than 2009, it will have a USB communications port, a USB-B it's called. It's a smaller USB, like a camera typically has, and it comes with a 15-foot cable. And that's about the limited range of USB is about 15 feet. If you're going any longer than that, you need to start using repeaters or something like that. So those cables are convenient, but they have limitations. The next option is the DG700 as a 9-pin serial communications port, and you don't typically see those on new computers these days, but it's nice having it on the DG700, because the big advantage is you can run thousands of feet with serial communication. So one option is you can buy a regular serial cable, and you want to get a straight through cable. There are some where, like, pin 1 will go to pin 6 or something. You want a straight through cable. So pin 1 is going to pin 1, and so on. And those communications cables you can get in lengths of 15, 25, 50 feet, and they have the ends connected to them already. So that's very convenient. We also have the DB9 9-pin to Cat5 adapter. Cat5 is regular Ethernet cable, Cat5 Ethernet cable, and we recommend you use stranded cable. If you use single conductor cable, it'll be hard to roll back up, and it won't be as durable as stranded cable. It'll end up breaking over time, and those single conductor cables get kinks in them, and they're hard to roll up. They're great if you're just rolling it out one time and leaving it there for the life of the house. But if you're continually rolling up, it's better to get stranded cable. And for both of these second two choices with the serial cable, you'll need a serial to USB adapter, and those do need drivers. So they'll come with a disk to install drivers, or you can go to their website and download the drivers. But hang on to those drivers, or where you can get those drivers, because if you want to use that cable with a different computer, you'll need to download the drivers first. So you can use virtually, we've run 3,000 feet of cable and not had any problem with loss of data. So virtually any length of cable will work. We also have the Wi-Fi link for wireless connections, and that has a DB9 9-pin connection that you'll screw onto the top of the gauge, in the screws that are already there, and it will get power from the tap, the AC adapter tap on the side of the gauge. So readily adaptable to any DG700 gauge. And you'll prepare the building for the test the way you would with any blower door test, where you'll close all exterior doors and windows. You'll open all interior doors. You'll turn off all devices that affect pressures in the home, and that could be exhaust fans, clothes dryers, attic fans, anything that could affect air handler, anything that could affect pressures in the home. And turn off combustion appliances, space heaters, furnaces, water heaters. You want to make sure those are all turned to pilot or turned off, so they won't come on during the test. And then once you have the building set up, you'll set up the blower door fan in a door opening, and connect your DG700 and speed controller. You want to make sure you have the fan control cable going from the side of the DG700 to the gauge, and run your tubing. We recommend, a lot of people have tried a lot of things for measuring pressure, from putting the tube in a 5-liter or a 2-liter bottle, some kind of pop bottle, or putting it in a sponge, or a lot of different things. And what we found is most effective, and we've done quite a bit of testing with various either commercial things that are on the market for commercial buildings for measuring outdoor references, or other things that people have tried, like an upside down pie pan on legs, or something like that. And we found either putting it in tall grass and covering it with some dead grass, maybe to help shelter it, or this is a picture of putting it on the leeward side of the house, the side of the house away from the wind, towards the center of the building where it's most sheltered, and taping it right up next to the building. And then if there's wood chips, that's great. Just kind of cover the end of it with wood chips or grass clippings or rocks or whatever is there, and you'll find that that's about as good a place as you can get. And in this case, we've taped it to the wall and have it pointing down, so if you have problems with rain, that won't be an issue either. So that's what we've had the most success with as far as choosing a location for your outdoor envelope pressure. And then you'll want to, if you're using the Wi-Fi link, this is showing the Wi-Fi link in operation. So once it's connected to your computer, connected to the software, you'll see all 4 lights blinking, indicating that it's sending data. Hi, we're ready to start a demonstration of using TECLOG3 to do a single fan blower door test. And we're using the Wi-Fi link. So our first step is we're going to connect to that Wi-Fi network in our DG700, along with the serial number is showing up as one of our Wi-Fi networks. So we will connect to that, and then we'll launch our TECLOG3 software. And we'll see this screen, and we'll go up to configuration, the pull down configuration menu, and choose settings. We'll go up to device type and choose DG700. We'll scan for ports and devices, and now we'll do a scan of all Wi-Fi, TEC Wi-Fi links, and any wired connections. And it found one Energy Conservatory device. Click OK, and then under serial number next to the DG700, we can double click that, and then our DG700 and serial number will show up here. If we had more than one gauge, we'd have a whole list to choose from here, and each one we choose, that would be removed from the list, so it makes it easy to get all those serial numbers entered in. And then we'll label that device south. We're on the south side of the house with that gauge. And then we'll go up to view and edit channel settings. You can see this bar here. We'll click on that. And we will change this to an envelope pressure. So channel A, envelope pressure. That color changed to green when we chose envelope pressure. And we'll give that a label of west. Wind is coming out of the east. Today we've got a storm coming in, so we're on the leeward side of the house, close to the house. And on channel B, we'll choose Model 3 fan flow. We see that change to red, and we'll call that lower level. And we'll click OK. And for our test standard, we're going to choose CGSB. We'll click on that. That's the Canadian General Standards Bureau, and that's what is normally in TECTITE. Those of you who are used to using TECTITE will recognize that. And then we'll click OK down here to close that out. We're done with the configuration. And we'll go up to recording and start recording. Now it's going to actually scan and make a connection with all those devices and start transmitting the data. So it'll search for all wired connections and Wi-Fi connections, and then it'll prompt us to save the file, to give the file a name. So it'll start saving the data right away. We'll give that a name and tell it where to save it so we can remember where to retrieve that file. And now we can see it's starting to record some data there. So our first step is we're going to take a baseline. So go up to baseline period of record. Click OK. And baseline period of record it's going to automatically check that we want this included in an air tightness test results and that this is a baseline. So we'll call that pre-base. Click OK, and we can see that name shows up here, and everything within this green dotted line box will be included in our baseline period of record. And while it's recording that data, we'll go up to Edit Test Details, click on that, and our indoor temperature is about 68, outdoor is about 38. So then it'll do that density correction for the temperature difference between indoors and outdoors. And if we want to include our test boundary surface area to calculate CFM per square foot of surface area, we can enter that information in here also, and that will show up on our test results. You'll notice there's two fan control slide bars here, a master controller and one for our gauge. If we had multiple gauges, multiple speed controller slide bars would show up there. And I'm just going to hide those so there's no confusion. And so we can either uncheck the master or uncheck the device ones, and I'll uncheck the device ones so we just have one master controller. On the right here, it'll show total flow. It's showing we only have one channel designated as a fan, and if we have multiple ones, it'll show how many of those are running and the total flow of all the fans here. And envelope pressures, it'll take the average of everything labeled in envelope pressure, and we only have one envelope pressure, so it's just showing what our current number is here, and then it's showing west and what the pressure is, and that our ring is sealed here. So now it's prompting us to add 4.2 pascals to our target envelope pressure. Our target is 50, and we want to change the building by 50, and this 4.2 is the average baseline period of record. For all of the data points in this period of record, it's averaging those. Yeah, and that's 4.2. So if we're going to change it by 50, we need to go to 54.2. So click OK, and we'll change our target here, target cruise, to 54.2. Okay, so now we're ready to start the fan. So I'll have to mark this as ring B, and then I'm going to go uncap the fan. Now we can click cruise fan. The cruise fan button here turns on the cruise. And it marked a line here now at what our target number is. And now our fan, you can see our fan controller is starting up here. And this will flash lowest fan pressure out of all the fans. It'll flash that until our fan pressure gets up above 30. It's just prompting us. Then it'll turn black. It's prompting us if that we're getting close to what our lowest fan pressure is, and that we'll need to switch rings, or if we've got multiple fans, we might just turn off a fan and cap it. So now we can see we're starting to get close to our cruise target here. This green line is our target, and we've got some wind gusts, so it's fluctuating a little bit, and we're pretty close to our cruise target. So I'm going to hit fan on period of record here, and now it has unchecked the baseline period of record, and we'll label that -50. We're actually cruising to about 54, but our induced pressure is 50. So click OK. So we can see what our envelope pressure is and what our flow through our fan is. Okay, so that's done now. So I'm going to click that up one now. So now we're at an induced pressure of 45. So we can see our numbers are leveling off at about a 45 for induced pressure. So we'll click another fan on period of record, and we'll call that -45. And then we'll keep an eye on our lowest fan pressure, or once that gets below 30, we'll have to switch to our ring C. We've got ring B on now. So it looks like the wind is picking up a little bit here. And I'm clicking the up arrow here next to our cruise pressure. There's an up arrow or a down arrow, and we're moving towards 0. So we're moving up with that. We'll click our next fan on period of record. And I'll call that -40. Click OK. So you can see it goes pretty quickly. It's not automated, so there's a little bit more work, and you have to stay a little bit more focused to make sure you're following this. So we're getting near the end of our period of record. We're going to be pretty close to 30 with this next one, but I think we can get another data point in there. We'll click up. We might get one more period of record in there yet. Let's click fan on period of record, and this is -35. And we go down to -15 with the CGSB. So we'll keep clicking 5 at a time until we get down to -15. And now we can check our results too here. It doesn't like us checking the results when it's recording data. We can see we're fitting along the line pretty good. We've got a little bit of scatter. Now we'll click up one more. It's nice having this green line across here at what our target pressure is, because then we can see pretty well when we're ready to do another fan on period of record. Now we're at -30. So now it's kind of giving us a warning. This will be the last period of record where we'll be using ring B, and we'll need to switch to ring A. So now when I switch that, I'm going to click the cruise off. So I'm going to turn the cruise off. The fan will remain running, but I'm going to put ring C on there. Then I'll click the cruise back on. Now it'll ramp up that. You can move. See, I clicked on the. You can move the screen around like you do with Google Maps. You can click and drag it. You can also go to Auto Y if you want. Then I clicked on Auto Y. Now it'll adjust that so everything will fit in. It'll fit in. And I need to change this to ring C because I've got ring C on there now. And I'll do a fan on period of record. And we'll call this -25. And we can also, there's a measurement tool over here up on the upper left of the screen. And I can click on that, and then I can move that across the screen, and it will show what the fan flow and pressure was at any point wherever that red line is. So that's kind of a handy feature, comes in handy sometimes. And then I'm going to click on the up arrow here. I'm going to look at our results. Our correlation coefficient is getting a little better. Our points are fitting better on a line. If something popped open, it would become pretty obvious on this line. So I'm going to click up one more to change our target. So it's slowing down our fan. We just got a few more points to go here. I'm going to move the screen over. Okay, our fan pressures are we've got a little bit of wind gyration here, so it's now we'll click a fan on period of record, and we'll call that -20. So after this one, we just have one more period of record, and then we can take our post baseline. So that's good. Our pressures are pretty stable. Our fan flow is leveled out there. And then we'll take our last period of record. There we go. Call that -15. Got a little bit of wind there. Okay, so then I'm gonna go fan off, and I'm gonna seal the fan. I need to go seal the blower door fan. And we'll do one more baseline period of record, and we'll call that our post base. So those of you that are used to using TECTITE, it's very similar, only instead of seeing a graph of all these pressures, you're just watching it plot the points on the screen. So some of the other things up along this upper bar here, so we saw that measurement tool. If we want to create a period of record, like let's say I could click on this, and you know, I could label, I could make a period of record here. I just did a right click inside that white box and chose create period of record, and I don't want to include this in a in the air tightness results, but if I had some reason why I wanted to make note of something else, if I'm doing some additional pressure diagnostics or something, I could create a period of record that way. I'm just going to cancel out of that. I'm going to unclick there, or I could create an event marker, like maybe when I change the flow rings, I could make an event marker. Let me put the I'll move this measurement tool to where I wanna create that event marker, and then I can create an event marker at that location saying changed rings. So it just gives you some options on other things you can include in the test. So it drew a marker here now, and it says changed rings. So now we finished our baseline period of record. So now we can go up to recording, and well, before we do that, let's take a look at our results to make sure that we're in 0.99. So it looks like we want our correlation coefficient to be above 0.99. Our CFM that's adjusted for density, for temperature, is 508, and we've got a exponent of 0.7, which is reasonable. Anything near 0.65 from 0.55 to 0.75 is typically where it'll run. So this looks like a good test. So I'll click OK here, and we will stop our recording. Would you like to load the test you just created? Yes. So now we'll go to our results page. I'm going to click on results up here again. And we're going to export this data to TEC Express. So it'll save this data in a way that we can retrieve it and open it in TEC Express. So I'm going to give this a name. It's called BD TECLOG3, and I'll put it on my desktop so I know where to find it. And it'll save this in a way where we can open it in TEC Express. So click OK. We'll minimize that, close that. So here's the blow-it file. So I'm going to open our TEC Express 4.0, and this is a free download from our website, TEC Express 4.0, and I'm going to retrieve an existing test. Up the file menu, retrieve existing test, and here's the one we just created. Now it pulled up that data in TEC Express. So if we want to generate a report that has all of this, all of our information in it, our name and the date, our customer name, our building information, volume, floor area, anything else, any other words you want to add to a report that you want included in this report. It's unlimited how much text you can enter into this page. Go to next, and now our graph will show up here, and our results. So all of that will show up. So then we can go up to File, and we can preview our test report, and all the information that we entered in there will now show up in this test report. So we got 2 pages of information that'll show up in a pretty slick report. We can also pull in our close that out. We have the option of putting our business information in here, so we could enter our name and address in all of this, and we can load a company logo into here, and then save all of that as a configuration file, save configuration file, and then when we start our tests each time, we'll choose new test with custom configuration, and we'll pull up that configuration file that we saved that has our company logo and name in, so we don't need to enter that every time. So when you initially download TECTITE, it's a good idea to create that configuration file that has all your company name and info in it, create that custom configuration, and then start a new each time you start a new test, instead of choosing new test, choose new test with custom configuration, and all of that information will be pulled in automatically. So that's pretty slick. And then you can print that test report. So you can either send that to a printer, or you can choose if you've got a you should have a PDF writer. If you don't, there's the one that I'm showing here is Qt PDF. That's a free download. It's a PDF writer, and you just print to a PDF writer, and it'll create a PDF file of that report, and then you can email that. So pretty slick. It's a little more work than an automated test like TECTITE, but this gives you an idea of what a blower door test looks like in TECLOG. If you want to use multiple outdoor references with using multiple gauges, you can do that. If you want to do a single fan test and have a full graph like this, that's an option. Having 4 envelope pressures, 1 on each side of the house, gives you a more stable baseline reading and more stable reference pressure during your test, so that's certainly an option too. So that concludes our demonstration. So we just took you through doing a blower door test and downloading or exporting that to TECTITE Express and opening TECTITE Express. Some of you may be used to using TECTITE, and you're probably curious on what the difference between TECTITE and TECTITE Express is. TECTITE, these are features that are unique to TECTITE that are not in TECTITE Express. The Wi-Fi connection for automated testing. You can't use that Wi-Fi option if you're using TECTITE Express, unless you're doing like we demonstrated, where you're recording it in TECLOG and exporting it to TECTITE Express. There are additional air tightness test options in TECTITE. Both of them actually do have the CGSB 149, so that is common to 2 of them, and then there's the 3 ResNet test standard options, either a single point, repeated single point, or multi-point ResNet test standards. It will calculate the estimated natural infiltration rate and annual cost of air leakage in TECTITE, and TECTITE Express does not do that. It'll calculate the need for ventilation based on ASHRAE 62.2, estimate design infiltration rates that can be used with manual J load calculations. And then you have your choice of reports. There's either a simple homeowner's report or a detailed technical report that gets into has more technical information in it. And it has compare features, so you could do a pre-test and a post-test on the same building, and then pull up a report that compares the 2. So that's kind of that's a nice option to have. And then it's got a built-in PDF file report generator, where it'll convert that report to PDF format. So that's a nice feature too. TECTIDE Express has a choice of 3 airtightness standards. The CGSB, which is in both, E779 is referenced. The ASTM E779 is referenced in a lot of different test protocols. It requires pressurization and depressurization testing, and tests at a minimum of 5 points between 15 and 60 pascals, and oftentimes it's used to go up to 75 pascals for bigger building testing. And then it also has the EN 13829, which is the used by the German passive house standard. Can combine both pressurization, depressurization in the same test file, and has your choice of English or metric. So those of you Canadians that are looking for metric, you've got that option. So we'll take some time here to answer any questions you might have, or if you want to call us for tech support using the software in the future, our phone number and website information is here. Okay, yeah, if you guys want to type in questions, go ahead. We did have one question that you've seen up on your screen now. John asked about connecting to multiple gauges, and you can only connect to one Wi-Fi network at a time. So you will need to use a router and connect all of your gauges to the router first. Put your gauges in router mode and connect to the router, and then you can connect to that router wirelessly on your computer and do it that way. So TECLOG will allow the connection of up to 16 DG700s. And if you need more than 16, you certainly could do that. You could either run 2 versions of TECLOG on your computer at the same time, or use multiple computers. So it's unlimited how many gauges you could use or how many fans you could use for a test. I also wanted to let you know that our iTech 700, the Android version, is now available. We put that up on our website this week. So that allows you to connect to a DG700 using a Wi-Fi link to any Android device, and view a DG700 gauge, do the pressures and flows and control the fan and set cruise wirelessly. So we're excited about that, and we're getting feedback from our customers on what additional things they'd like to see in an app. A real common one is doing an automated test wirelessly off of an iPad or a Android device or an iPhone, and we're working on that. I'm not promising any finishing dates, but we have been working on that. So that concludes our webinar for today, and we will be putting a link to this on our website. So if you want to view it again or let other people know about it, feel free to do so. John has a question about editing a PDF. You would need to have a PDF writer software where that allows you to edit PDFs in order to edit that document. If you wanted to include additional information in the report, but probably the best way to do that is on that page where you can add additional things to your report. You can make notes or add any additional things in there. The amount of text you put in there is unlimited. The number of pages of additional information, of additional text you want in there is unlimited. Oh, I'm sorry. You're referring to. I was reading that wrong. I was. So you're talking about a period of record. You can go back and delete a period of record, and then create a period of record in a different location. And so that's one really nice thing about this. Sometimes you'll get back to the office and you'll be viewing that report and you think, oh boy, I should have, that the fans were still adjusting during that period of record. I need to move that over, or I need to delete that period of record. You do have that option after you open up the test file to go back and do some edits to the file.